Let's talk about the different systems of measurement that we're going to want to be familiar with in chemistry. First of all, we have the metric system, which is an international standard that's based on the decimal system, so all powers of 10. We have the SI system, which stands for International System of Units, or Système International, the French phrase that the acronym comes from. And that's a formalized version of the metric system. It uses 7 base units, which we're going to write down in a moment, and we're going to want to learn. And then from those base units, derived units are made. The system you're familiar with probably, though, is the British system or the imperial system, which uses feet, pounds, inches. And of course, that's not based on the decimal system. In other words, there's 12 inches in a foot and there's 3 feet in a yard. So that's not going to be used by the scientific community. As a matter of fact, it's only used by a small number of countries. So let's talk about the SI system, which is based on the metric system, and that's the system that scientists use. We're actually going to write down some of these things. You can see some of these are in yellow, and those ones that I've highlighted yellow here are the ones that we want to be familiar with. But I'm going to show you these notes handwritten so that you can copy them down. These are the notes that you'll want to have to review. So let's begin by making a data table. And in that data table, we're going to have 4 columns. The data table is going to describe the International System of Units. And we're going to make 4 columns. One for the unit name, one for the unit symbol. For example, the unit name would be the meter, and the unit symbol would be a lowercase letter m. And then next, 2 more columns, one for the quantity that the unit corresponds to. So what's the name of the quantity that the meter describes? And what's the symbol for the quantity that meters describe? In other words, meters describe distance or length, and we'll use the letter D for distance or the letter L for length. So those are our 4 column headings. And now we're going to just separate these rows, and we're going to fill in the data table that you saw on the slide a moment ago. And I'm doing this slowly and deliberately so that everybody can have the time to copy this down together as we go. The few that we're going to want to memorize of these, we're going to put an asterisk next to. And one of them is the meter, which is the base unit for distance. Its symbol is a lowercase letter m. We measure distance or length, if you prefer, in meters, and we use the letter D or the letter L for length or distance. And that's one of the ones that we're going to want to memorize. Also, the unit kilogram is a base unit. Notice it's interesting that the base unit is a kilogram, not a gram, and the symbol for the kilogram is kg. We'll talk about prefixes in a minute. The quantity that kilogram measures is not weight, but rather mass, and we want to distinguish between mass and weight. That's one of our learning objectives in this unit. The letter M is the symbol for mass. So let's keep going. There's 7 of these all together, and some of them are more commonly used in chemistry than others. Sometimes we do need to talk about time, and the SI unit for time is the second, and its symbol is a lowercase s, lowercase letter t for time. The uppercase letter T is going to come up in a moment. It is going to be for a different quantity. Uppercase letter T is for temperature. And temperature, you may be familiar with some common units of temperature like Celsius and Fahrenheit, but in the SI system, temperature is measured in kelvins. 1 Kelvin, 2 kelvins, and the unit symbol is an uppercase K. So there's the 4 that we're going to start with. Those are all the ones that we're going to put an asterisk next to. The next 3 are a little bit less commonly used in chemistry, so we don't need to memorize those. However, We're going to list them here because they comprise the 7 base units of the SI system. The mole is one that is actually central to chemistry, but it's not going to come up until later in the year. So it's not one that we need to get familiar with just yet. The mole is the SI unit for amount, and its symbol is a lowercase letter n. The other 3 are definitely less common in chemistry, and those are the candela, which measures luminous intensity, and the symbol for luminous intensity is an italicized uppercase I, and then finally current, which is a non-italicized uppercase I. I didn't make these rules. It does seem to be a poor choice here between these 2 symbols, but we're talking about electrical current here, and it's measured in a unit called the amp or ampere. So there are our 7 base units of the International System of Units. Go ahead and make these lines a little longer, and hope they had a chance to write those down. The ones listed at the top we have an asterisk next to because they're ones that you want to memorize the information for. Now, these are all what we call base units, and we're going to next talk about derived units. The beauty of the International System of Units is that it only uses 7 base units, and all other derived units can be built from them. So I'll give you a few examples of those. Here, once again, are the 7 base units we just talked about in a slightly different order. We're going to talk about prefixes that are used in the metric system before we go on to derived units. And there are many prefixes. You may have memorized acronyms to keep those straight. But the 4 that are most commonly used, which we want to memorize, are listed here. So we're going to write these in our notes right now as well and make sure we understand these metric prefixes. Of course, metric prefixes can be added in front of any unit. So I could talk about the kilogram or the kilometer or the kiloliter. And we'll make another short data table here that'll only take a minute. And the 3 columns will be for the prefix name, the prefix symbol, and its meaning. And while there are many that are used, including especially in computer science, giga, tera, petabytes, the ones that we'll want to memorize are micro, milli, centi, and kilo. So I'll draw the lines around this data table, and then we'll fill in the rest of it. The prefix symbols are, first of all, this Greek letter mu, which is sort of like a U with a tail on the front. And then a lowercase letter m can mean m for mass, or m for milli, or m for meter. Lowercase letter c and lowercase letter k. Now, the meaning of each of those is essentially a order of magnitude. Micro means times 10 to the negative 6th. That means millionth. Milli means times 10 to the negative 3rd. That means thousandth. Centi is times 10 to the 2nd, which is hundredth. Negative 2nd, which is hundredth. And finally, kilo is 10 to the 3rd, which means thousand. So notice the kilo prefix is a multiplier, not a divisor. So let me clean this up a little bit. Hundredth. There we go. There's our metric prefixes. So we'll want to understand their meaning and also be able to think about scientific notation like this. This means if I wanted to convert from meters to micrometers, I would need to move the decimal 6 places to the left in order to make it a very small division of a meter. And if you ever need to go back to this video to write down the notes, of course, that's an option, but I'm going to move on to the last slide I wanted to include here, which is the introduction of the idea of derived units. So derived units are built from other units. For instance, the unit of force is the Newton, but a Newton is just an easier way of saying a kilogram meter per second squared. So you can see that it's built from all of the other base units. Energy is measured in joules. Well, a joule is just a Newton meter. In other words, a kilogram meter squared per second squared. Velocity is in meters per second. Now, this is an error here. I'm not sure why that says centigram, but that would be m/s. And the volt, you can see, is built from many other units of measurement. It's an electrical potential energy unit, and you can see it can be defined in terms of amperes, which are built in there. So those are the base units which build all of the derived units. In the next video, we're going to talk about an important derived unit, and one of the reasons the metric system or the SI system is so helpful is that we're going to relate units to each other in this way. So the units of mass and distance and volume can all be related. So we'll save that for the next video.